chapter number 3. The next is chapter number 4. In chapter number 4, there are 2 topics. The first one is vector. Basically 3 topics: vector, projectile, and circular motion. I have already taught vector in the classes that I took in vacations. So you all were there in those classes. Sania, you have attended those lectures of vector?
Yes, sir.
Fatma, Sharif, you were there?
For one class I was there.
You have missed one class or just have attended one class?
I just attended one class.
Attended one class only. Okay. And Fazil and Noor?
I missed the last class.
Yeah, missed the last class. And this projectile and circular motion, did your teacher did these 2 topics in class?
No.
So what you want? You want me to continue with these topics, or should we do this once after completing laws of motion?
After laws of motion.
After laws of motion. So let's do one thing. I have to teach vectors, but since few of you have already completed vectors with me, so I'm not taking vectors in the regular class. We can have some extra classes for vectors. Because in chapter number 4, this projectile and circular motion are not being taught in your school, so we can skip it for the time being. But these 2 topics are very important. Even in laws of motion, I will need this topic. So I will cover this circular motion with laws of motion. But as far as projectile is concerned, we can skip it for the time being. The vector, this I have discussed in class with few of the students. So I will not cover vector in the regular class, but we can do vector in extra classes as a backup. So let's start with chapter number 5. But even for chapter number 5, I will need some introduction of it. I'm just introducing vector. So vectors are those quantities which have magnitude as well as direction. So vectors are quantities having magnitude, direction, and following vector laws. So quantities which have magnitude as well as direction and they follow vector laws are known as vector quantities. The examples include displacement, it's a vector. Velocity is a vector. Acceleration is a vector. So these are examples of vector quantities. We represent vector by an arrow. If I put arrow on a quantity, that means it's a vector quantity. It have both magnitude as well as direction. This quantity have both the things. This quantity have magnitude as well as direction. Or in NCERT never use this notation of arrow. You will not find any arrow in NCERT. In NCERT, whenever you have a vector quantity, you just bold that quantity. That bold quantity will represent a vector. For example, let's say you have force. Force is a vector. A force of 2 Newton due east. So this 2 Newton is the magnitude of force. This is the magnitude. And the rest is direction. So the magnitude of force is 2 Newton. So if you want to represent only magnitude of vector, only magnitude, we can represent the magnitude of vector as this. Modulus of F is 2 Newton. This is the magnitude of force, which is 2 Newton. The direction of force is due east. Direction is due east. So no need to write direction separately. If you want to represent the direction, the magnitude of a vector, the magnitude we represent either in mod or just by writing it. We don't make it bold. If you make it bold, then it's complete vector. If you want to represent only the magnitude, then just either put bars with vector A or just remove the vector that's represent magnitude. Say here magnitude is 2 Newton, so you can write mod of F is 2 Newton, or you can simply write your F is 2 Newton. So this is how we represent a vector quantity. Geometrically, vector is represented by an arrow. So we can represent a vector by an arrow geometrically. This is how we represent a vector. This is known as the head of vector, and this is known as the tail of vector. This is head and tail of vector. This is how we represent a vector geometrically. Okay, just note it down. Tell me one thing. I have to give backup of vectors to Fatima, Farhana, Fatima, Sharif, and Rania. What about the rest of you? Noor, Fazil, and Sania. Do you need backup of vector or you remember all things? Because if all of you need backup of vector, then I can continue the whole vector in this class only.
Sir, I need.
You need. Who? Sania?
Sanya, yeah.
You need backup of complete.
Yeah, because I did only one class.
You did only one class. And what about Fazil and Noor? You want complete backup of vector or not?
There only that polynomial law I don't remember. Other than that, I remember vectors.
Other you remember. And Fazil?
Yes, sir. Same, the last part.
The last part. Which one? The polygon law?
Yeah, because after that I hadn't attended.
Okay, so it's better I should repeat the whole vector because that polygon law is just the starting of vector.
Okay.
Polygon law is just the starting of vector. So it's better I complete the whole vector itself in class. So let's continue with the complete vector now. So vectors are simply quantities which have magnitude, direction, and they follow vector laws. So Rania, Fatma, Farhana, and Fatma Sharif, I'm completing the whole vector in the regular class only.
Okay, sir.
So this vector is part of chapter 4. Chapter 4 of NCERT. The story of vectors starts with the concept of physical quantity. These vectors are important because without vectors, I can't teach you neither laws of motion nor work energy power. In each and every step of vector, you will, of laws of motion and work energy power, you will use this vector. So the story of this vector starts with the concept of physical quantity. Physical quantity means quantities that can be measured. Each and every quantity that you can measure is a vector. You can measure speed, you can measure velocity, you can measure acceleration, you can measure force. So whatever the quantities that can be measured is a vector. You can divide these vector quantities into two categories. Whatever the quantity that you can measure is a physical quantity. You can divide physical quantities into two broad categories. It can be either a scalar or it could be a vector. Scalar simply means quantities that have only magnitude. Quantities having only magnitude are known as scalar. They don't have direction, no direction. The examples include mass is a scalar, distance is a scalar, speed is a scalar. These are scalar quantities. On the other hand, vectors are quantities which have magnitude, direction, and they follow vector laws. Like you can't add vectors algebraically. In vectors, 2 plus 2 is not always 4. In vectors, 2 plus 2 could be 0, 2 plus 2 could be 1, 2 plus 2 could be 3, but it's not always 4. So these are vector quantities, which have magnitude as well as direction, and they follow vector laws. Just note it down and let me know if you have any doubt in it. So can I raise it?
Yes, sir.
Yes, sir.
Getting vectors?
Yes, sir.
It's a completely independent topic.
Yes.
Okay. So the first thing we start vector with the concept of unit vector. We have few definition in vectors, like some very basic definitions like equal vectors. Equal vectors simply means vectors which have equal magnitude in same directions. Equal vectors means vectors having equal magnitudes and same direction. So if you have two vectors which have equal magnitude and same directions, they are known as equal vectors. Like if this is vector A and this is vector B, they're acting in same direction. So you can write this as vector A is equal to vector B. This is equal vector, having equal magnitude and same direction. After equal vector, there is one term negative vector. Negative vector simply means two vectors are negative of each other if they have same magnitude but they're acting in opposite directions. So negative vector means vectors having equal magnitude and opposite directions. Say this is vector A and this is vector B. They both have equal magnitudes, but their directions are opposite. So we call them as negative vectors. A is minus of. For example, say you have a force of 2 Newton due east. Sani, can you guess the negative vector of F1? If F1 is a force which is 2 Newton due east, and what would be the negative vector of F1? Vector having same magnitude but exactly opposite directions. So F1 and F2 have exactly same magnitudes but opposite directions. So they are equal vectors. Is it clear? Equal and negative vectors?
Yes, sir.
Okay. After equal and negative vectors, the next is parallel vector. So this parallel vector use one condition of equal vector. These parallel vectors have same directions. So vectors acting in same directions are parallel. Magnitude may or may not be equal. So if I'm saying two vectors are parallel, this is vector A and this is vector B. If they are parallel, that means they're acting in same directions. For example, if one force is 2 Newton due east, another force is 3 Newton due east. Sharif, are these two vectors equal? Fatma Sharif. 2 Newton due east and east. Are these two vectors equal, Fatma? Equal?
No.
No. These two vectors are not equal because for two vectors to be equal, they should have same magnitude, but they have different magnitudes. But can I say they are parallel? Yes,
Yes.
they are parallel because they're acting in same directions. After parallel vectors, next we have anti-parallel vectors. Next we have anti-parallel vector. Anti-parallel vector means vectors which are acting in opposite directions. Vectors which act in opposite direction are anti-parallel. So if you have a vector A which is acting to the right hand side, then the anti-parallel vector will act in left hand side direction. They just act in opposite directions. So if I say that F1 is 2 Newton due east, and I take another force F2, which is 3 Newton due west, then are not equal. So I can't say that they are anti-parallel. But since they are acting in opposite directions, so their magnitudes are not equal, so they are not negative of each other. But since they're acting in opposite directions, we can call them as anti-parallel. Please note it down.
Done, sir.
So Fatma, Rania, can I rub it?
Yes, sir.
Yes, sir.
Let's erase it. These were some very basic definitions. The next is the concept of unit vector. So unit vector simply means a vector having magnitude of unity. So unit vector is simply a vector having a unit magnitude. Magnitude of 1 is unit vector. So unit vector is a vector having unit magnitude. So vector which have magnitude of 1, magnitude of unity is known as unit vector. So the difference between a general vector and a unit vector is, in general vectors can have any magnitude. Force is a general vector. It can have magnitude of 2 Newton, 5 Newton, 7 Newton, any magnitude. But unit vectors have magnitude of unity. If I say I have a force of 1 Newton, then it's a unit vector. There is no restriction on direction. It can act in any direction. The only restriction is on magnitude. You can have a velocity, a 1 meter per second, it can act in any direction. You can have a displacement of 1 meter. It can act in any direction. So whenever magnitude is 1, we call that vector as unit vector. So vector having unit magnitude. So just to differentiate between a usual vector, which can have any magnitude, and a unit vector having magnitude of 1, we use a different notation here. We use cap. We call this as a cap or a hat. So whenever you have cap over a quantity, that means it's a unit vector, its magnitude is 1. So the magnitude of a cap is 1. See, for example, I'm taking a force of 2 Newton due east. Rania, is it a unit vector? Rania is 1. Is it a unit vector?
No.
No. If I make it 1?
Yes.
So whenever magnitude is 1, it's a unit vector. So we put a cap over it. A force of 1 meter per second at 30 degree with x-axis. Direction does not matter. Only the magnitude matter. Magnitude should be 1. In fact, if I just write n cap, Noor, can you mention its magnitude if I write just n cap?
1.
Whenever you have cap, no need to specify the magnitude. Its magnitude is always 1. Just one more thing. If you have a unit vector n cap in the right hand side, then just the opposite direction, you can take a unit vector minus of n cap. This negative sign will show that it's acting in opposite direction. Along positive x-axis, if it is n cap, then upon negative x-axis, it's minus of n cap. So these are unit vectors. So in unit vectors, only magnitude is fixed. Its magnitude is 1. It can have any direction. So even if I take magnitude of minus n cap, it comes out to be 1. Magnitude of a vector can never be negative. Negative sign just shows the direction. Negative sign always represents the direction. So even if you have a negative vector, its magnitude is plus 1. Next, we have some universal unit vectors. Universal unit vectors means these are unit vectors where directions is also fixed. Not just magnitude, even directions is fixed. Say this is x-axis. This is y-axis. This is z-axis. This is x-axis. This is y-axis. This is z-axis. So along x-axis, we consider a unit vector I cap. So whenever you have I cap simply means it's a unit vector along x-axis. Along y-axis, we have a unit vector which is j cap. So whenever you have j cap, that means it's a unit vector along y-axis. Along z-axis, unit vector is k cap. So whenever you have k cap, the direction is z-axis. Z-axis is perpendicular to the plane of this board, or is perpendicular to the plane of your copy. If you place this pen on the copy such that this pointed ends is outwards, out of the plane of the copy, that's your positive z-axis. Your negative z-axis is into the plane of copy. Board is two-dimensional. I can't draw that outwards direction. Z is basically outwards, coming out of the plane of my laptop. So that outwards direction we represent as this in this way. This doesn't mean this is in the plane of board. This is perpendicular to the plane of board. That's z-axis. So if I write I cap is unit vector along x-axis. It's a unit vector along x-axis. J cap, it's a unit vector along y-axis. K cap, it's a unit vector along z-axis. So I cap, j cap, k cap are unit vectors along x-axis, y-axis, and z-axis. So towards negative x-axis, we can use a unit vector minus I cap. Towards negative y-axis, we can use a unit vector minus j cap. And towards positive z-axis, we can use a unit vector minus of k. So these unit vectors have fixed direction. Wherever you have I cap, that means it's along x-axis. J cap always means along y-axis. And Fatma Sharif, what about the magnitude of I cap? Fatma Sharif, what is the magnitude of I cap?
1.
I cap, j cap, k cap. All magnitudes are 1. All have one magnitude. Okay, just note it down.
Done, sir.
Done, sir. Finished.
Okay, so let's erase it. So see how we use unit vector in physics. First example, if I say that I have a force of 3I cap Newton, this is force 3I cap Newton. Its magnitude is simply 3 Newton, but its direction is I cap, means direction is along x-axis. Direction is along x-axis. One more example. Say if I say that I have a velocity of minus 5 k cap meter per second. That means the magnitude of velocity is 5 meter per second, but the direction, Fatma Sharif, what's the direction of this velocity? Fatma Sharif, direction of this velocity. Fatma.
Z. Z.
Z, positive Z or negative Z?
Positive.
Negative Z. See, it's minus 5k.
Oh.
And say the direction is negative. So this is how we use unit vectors. These unit vectors you will use to specify directions. I cap will specify x-axis, j cap will show y-axis, and k cap will represent z-axis. Okay. The next is a representation of vector. The next is one form, which is known as Cartesian form. In Cartesian form, we represent direction using I cap, j cap, and k cap unit vector. If I write your vector A is, it's A1 I cap plus A2 j cap plus A3 k cap. So this particular form is known as Cartesian form. Here A1 I cap, A2 j cap, A3 k cap means that magnitude of vector along x-axis is A1. Magnitude of vector along y-axis is A2. Along z-axis, its magnitude is A3. So we write this as A1 is component of vector A. Component means part of vector A along x-axis. A2 is component of vector A along y-axis. A3 is its component of vector A along z-axis. So these are the components. Component means part of vector A which is acting along x-axis is A1. Part of vector A which is acting along y-axis is A2 and along z-axis is A3. If I ask you to calculate the magnitude of complete vector, then the magnitude of complete vector is root over its A1 square, the coefficient of I cap square, the square of coefficient of j cap, the square of coefficient of k cap. So it's A1 square root over A2 square plus A3 square. This is how we calculate magnitude of a vector. Let's take one example. If I'm writing that I cap is minus 2I cap plus j cap plus 2k cap, and I ask you to calculate the magnitude of vector A, and the magnitude is root over, the coefficient of I cap is minus 2, so I write this as minus 2 square. The coefficient of j cap is 1, so it's 1 square. The coefficient of k cap is 2, it's 2 square. So the magnitude of vector A is, it's 4 plus 4, 8 plus 1, 9, so it's 3. So this is how we calculate vectors, the magnitude of vector which is given in Cartesian form. Doubts? Is it clear or you have doubts in it? Is it clear?
Yes, sir, it's clear.
Everyone?
Yes, sir.
It's clear.
Okay, just note it down. Then we'll do see how to add and subtract vectors if they are given in Cartesian form. Can we have one class on Friday at the same time? Friday evening, same time. Just please mention availability in the chat room if you are available on Friday.
Yeah, sir.
The same time, right? 6 to 8 as per your time. For me, it's 8:30. If you're available 6 to 8, just please type yes in the chat room, otherwise, no. I just want to speed up the thing. Speed up. So, okay, Fatima Farhana is available. Fazil is not.
Sir, morning or Saturday?
Evening, same time. Friday evening. Fazil, you have any other class?
No, sir. I'm busy.
Sorry?
No, sir.
So you have any other class at the same time? Because it says you are not available.
No, I'm just not available.
Sorry?
I don't have other class, but I'm busy at that time.
You're busy somewhere else.
Yes.
Not sure.
Me also, sir.
Okay. No, sir. Okay, let me find any other timing that can suit you. So, can I rub it?
Yes, sir.
Sir. Yes, sir.
Can we have one class Friday morning? Friday, 8 to 9:30 a.m. Just report your availability. Yes or no? These two classes are fixed, like Monday and Friday are fixed. But I may need one or two extra classes just to match the syllabus with that of your school.
Yes, sir.
So, just write yes or no in chat room. I got confirmation from Noor and Sani only. Fatima is available. Rania is available. Fatima is again available. And only, very good, all are available. So let's keep it at Friday 8 to 9:30. Yeah? The next class is on Friday 8 to 9:30. But still we have half an hour left. We can complete at least Cartesian form. So let's start with the question. Say you have a vector I cap minus j cap plus k cap. So calculate first part, the magnitude of vector. In the second part, you're supposed to calculate the unit vector of vector. See, to calculate magnitude, so Sania, what is the magnitude of A here? If A is I cap minus j cap plus k cap,
1
it's 1 square.
I cap plus J cap.
No I cap, just coefficient. Coefficient of I cap is 1 square. Then
1 square plus
minus 1 square, right? And what's the coefficient of k cap now? Sania.
yes,
Yes, what is coefficient of k cap? 2 square, right? So the magnitude of vector A would be, it's 1 plus 1 plus 4. So the magnitude is root over 6. So this is the magnitude of vector A, which is root over 6. This is magnitude of S, first part of the question. Is it clear to calculate magnitude?
yes, sir.
Yes, sir. Yes, sir.
I ask you to convert this into a unit vector. So unit vector means to make it magnitude 1. To make magnitude 1, the best thing is divide vector by its magnitude. You can consider this as a formula of unit vector. Okay, do one thing. Write this formula in unit vector. Just after the definition of unit vector, where I have written A cap, just mention this formula there. It's vector A by magnitude of A. It's vector by its magnitude. So here unit vector A cap is its I cap minus j cap plus 2k cap divided by the magnitude of A, which is root over 6.
Root 6.
You can write your vector A as I cap by root 6 minus j cap by root 6 plus 2k cap by root 6. So this is how we calculate unit vector A. I cap by root 6 minus j cap by root 6 plus twice of k cap by root 6. Is it clear, everyone?
Yes.
Okay, just note it down. We'll do more numericals now. Okay, so I'm erasing it. Let's start with next topic. Addition and subtraction of vector A. The next is addition and subtraction of vector. Subtraction of vector in Cartesian form. So if you have vectors given in Cartesian form, you have to learn how to add or subtract those vectors. So you have a vector A, which is A1 I cap plus A2 j cap plus A3 k cap. Then you have another vector B, which is B1 I cap, B2 j cap, B3 k cap. And I ask you to add them up. See, addition of vector form is very straightforward. In Cartesian form, vectors get added up just like equations. Like I cap will get added up with I cap, j cap will get added up with j cap, and similarly k cap with k cap. If I ask you to add them up, then it's very simple. Like add A1 with B1 I cap, A2 with B2 j cap, A3 with B3 k cap. Similarly, if I ask you to subtract these vectors, if I ask you to subtract A from B, then this is simply subtract A1 from B1 I cap, A2 from B2 j cap, and A3 B3 k cap. So this is how we add or subtract vectors if they are given in Cartesian form. Okay, just note it down. We'll erase it and solve some numericals on this concept. Okay. So can I erase it? Written?
Yes, sir.
Everyone?
Yes.
Yes.
Okay, I'm erasing it. Okay, solve this question. You have a vector A, which is 2i cap minus j cap plus 3k cap. You have another vector B, which is I cap plus 2j cap minus 4k cap. This have several parts, but first solve, just add them up, and the second part just subtract them and report your answer in chat room. Just add these two vectors and subtract these two vectors and report your answer in chat room. I want answer of each one of you. Answers. Okay, Fazil. Fine. While writing your answer in chat room, don't worry about cap. Just write 3i, j, k. That's it. Okay, just one answer, and that is from Fazil. What about the rest? Sania, Fatma, Rania, Noor, answers. Okay. Okay. Good. So if I solve part 1, that's pretty straightforward. Huh? A plus b is just 2i cap minus j cap plus 3k cap, and vector b is I cap plus 2j cap minus 4k cap. So if I add them, vector a plus vector b would be 2i cap plus I cap is 3i cap, minus j cap plus 2j cap is j cap, plus 3k cap minus 4k cap is minus k cap. That's vector a plus vector b. If I subtract them, like vector a minus vector b, which is 2i cap minus j cap plus 3k cap, minus is I cap plus 2j cap minus 4k cap. If I subtract them, then 2i cap minus I cap will be I cap, minus j cap minus 2j cap will be minus 3j cap, 3k cap plus 4k cap will be 7k. This is vector a minus vector b. Okay, so almost all are correct. Huh? So we add or subtract vectors just like equations. So that's part. In the third part, if I say 5 times vector a, 5 times vector a plus 10 times vector b plus, or if I write this as twice of vector a plus 3 times vector b plus or minus 10 times vector c is 0, then calculate c. and C cap. So to calculate C, you can use this equation is 2A plus 3B. It's minus 10C. You can bring this 10C to the right hand side. So this will be 2A plus 3B is 10C. Next, you can just write your C as it's 2A plus 3B divided by 10. So you can just write this as this is 1 by 10. It's 2A twice of 2I cap minus J cap plus 3K cap plus 3B, which is 3I cap plus 2J cap minus 4K cap. So vector C is it's 1 by 10. If I multiply it here, it's 4I cap minus 2J cap plus 6K cap plus 3I cap plus 6J cap minus 12K. So vector C comes out to be, it's 1 by 10. See, 4I cap plus 3I cap is 7I cap. Minus 2J cap plus 6J cap is 4J cap. Plus 6K cap minus 12K cap is minus 6K. So this is vector C, 1 by 10, 7I cap plus 4J cap minus 6K cap. This is vector C. And for C cap, you would need the magnitude of vector C, or you can write this further as this is 7 by 10 I cap, 4 by 10 J cap, minus 6 by 10 K cap. So is it clear? You're getting it? This last step.
Yes, sir.
Okay. Now calculate C cap. For the same part, calculate C cap. Just note it down and then calculate C cap. If anyone have doubts, please tell me. If you don't have any doubt, then your C cap should not be wrong. Just calculate C cap. If you don't have any doubt in this calculation, try calculating C cap. It's okay. It's okay. So I got just two answers, one from Fazil and another from Shehbaz. What about the rest? To calculate C cap, I need magnitude of C, which is 7 by 10 square, 4 by 10 square, minus 6 by 10 square. Noor, I think you're making some mistakes in taking magnitude. It's 49 by 100. Yes, now you are correct. 16 by 100, 36 by 100. So the magnitude of C is, it's root over 101 by 100. Or this is 101 by 10. The unit vector of C is its vector divided by its magnitude. So this is 1 by 10, 7i cap, plus 4j cap, minus 6k cap, divided by the magnitude, which is root over 101 by 10. So this 10 will comes out to be in numerator, so this will cancel this 10. Yes, it will comes to be numerator. So your C cap is, it's an I cap, 4j cap, minus 6k cap, divided by root over 101. Is it clear?
Yes, sir.
Yes, sir.
So all were getting right answer almost. Okay, just note it down and I will erase it. Rania, Fatma.
Done, sir.
Okay, so let's erase it. This was about addition and subtraction of vectors in Cartesian form. After addition and subtraction in Cartesian form, the next topic is representation of vectors. See, we can represent vectors in two forms, in following two forms. The one is Cartesian form. In Cartesian form, vector is given in terms of I cap, j cap, and k cap component. A1 I cap, A2 j cap, A3 k cap. Then the next form is polar form. In polar form, angle between the vectors is given. So while adding, subtracting, or multiplying vectors, first you have to identify whether your vector is given in Cartesian form or your vector is in polar form. For both the forms, results and methods are different. Cartesian form is the easiest thing to do. In Cartesian form, while adding or subtracting vectors, we just add I cap, j cap, and k cap components. But now we have to see how to solve this polar form, how to add or subtract vectors if they are given in polar form. Okay, just note it down. I will rub it. Let me know when you have written. Okay. Sania, Rania, can I rub it?
Done, sir. Yes.
Okay. The next is addition and subtraction of vectors in polar form. Let's start with addition. Addition of vectors in polar form. Addition of vectors in polar form. So to add vectors in polar form, we can use one of the three methods. Either we can use parallelogram law, or we can use triangle law, or we can use polygon. So we can use any of these three laws, either parallelogram law or triangle law or polygon law, to add vectors in polar form. Just note it down. We'll start with parallelogram. If vectors are given in Cartesian form, then addition is very straightforward. Keep on adding I cap, j cap, and k cap. But if your vectors are not in Cartesian form, then to add these vectors, you will need one of these laws, either parallelogram law, triangle law, or polygon. So I am erasing it, right? Let's start with parallelogram. Can I extend this class for 10 minutes only? It will take 15 to 20 minutes. So I just have left with 10 minutes. I'm extending class just by 10 minutes. Parallelogram. So there are some criteria to use parallelogram law. Yes, sure, Fatma. Fatma, just, and everyone who is not in WhatsApp group, please WhatsApp me your number on this number. I will add you in group. Please WhatsApp me on this number. If you are not in our WhatsApp group, because we share assignments and everything on WhatsApp group, just send me a WhatsApp on this group. I will add you. So parallelogram. To use parallelogram law, so it's +91, it's Indian number, +9. Criteria to use parallelogram law. To use parallelogram. So the first criteria is you can use parallelogram law only for two vectors at a time. It can deal with only two vectors at a time. Two vectors at a time. So parallelogram law can deal with just two vectors at a time. It can't deal with more than two vectors. Second, vectors should be coinitial. Vectors should be coinitial. So while using your parallelogram law, your two vectors should be coinitial. You should have coinitial vectors here. Coinitial means vectors having same starting point. Coinitial vectors simply means vectors which have same starting point. So if two vectors are given in this way, this is vector A and this is vector B, they are inclined at an angle theta. So these two vectors have exactly same starting points. You can say that these two vectors are coinitial. Coinitial vectors have exactly same starting point, so they are coinitial. So the criteria to use parallelogram law is it can deal only with two vectors at a time. It can't deal with more than two vectors at a time, and the vectors which are given should be coinitial. So if I ask you to add vector A and vector B, and on adding vector A and vector B, you get a vector R. This plus sign here is vector addition. See, only the symbol of vector and algebraic addition match. There is no similarity between vector addition and algebraic addition. Else than this sign, the sign of algebraic addition and vector addition is same. Which means if A is 2 and B is 2, then 2 plus 2 in algebra it should be 4. But here in vectors, this 2 plus 2 could be 1. This 2 plus 2 could be 3 or anything in between 0 and 4, depending upon the angle between. That's why I'm saying this vector addition is different from your normal algebraic addition. It's quite different from algebraic addition. It's not same as that of vector addition. Okay, please note it down.
Done, sir.
So I don't think we can complete parallelogram law today. Let's stop it here only. This just one small issue. I have another class at 8 a.m. on Friday. So can we do this class at 10 a.m. on Friday? 10 to 11:30. I already have one scheduled class from 8 to 10.
Yes, sir.
Everyone, just put your responses in chat room. 3, 4. Fatma Sharif, so let's keep at 10 to 11:30. Okay, as per your Bahrain time, it's at 10 to 11:30. We will try to finish up to polygon law by Friday. Okay, let's stop here. We'll continue with parallelogram law on Friday. And this Fatma, Rania, everyone can leave, but please Fatma, Rani, Fatma, Farhana, Fatma, Sharif, and Rania, please stay for 2 or 3 minutes. I have to discuss some backup timings with you.
Okay, okay, sir.
See if you want.
Okay, sir. Thank you.
Okay, bye.
Allah Hafiz.
Okay. So Fatma, Farhana, Fatma Sharif, and Rania.